Hello, this video is going to be on exponents and the different laws of exponents. This is section 5.1, or it's, oh goodness, I don't remember. I never remember the other ones because they changed the chapters for my other text. But anyway, so exponents, let's look at some basic examples and make sure you remember some things that they assume you remember. First of all, anything to the 0 power is 1. So whether it's x to the 0 power, it's 1, or you have, I don't know, 2xy to the 0 power, that's going to equal 1. And the reason why is a division problem, and I'll show you kind of when we do the division why that ends up being that way. But one thing you can never have is 0 to the 0 power. That is like dividing by a 0, and so it is undefined. So there's only a couple things in math you can never do. You can never divide something into 0 pieces. Think about that logically and what division is. You can't take something and spread it into nothing. It still is something. So that's why dividing by 0 is impossible. Also, 0 to the 0 is a similar type logic, and so you can't do it as well. All right, let's look at a couple mistakes a lot of you will make on your calculator. Let's look at -2 squared, and let's look at -2 squared, like this. So look at the two squares. You have -2 squared like with a parenthesis and without one. The difference is this problem is like saying negative and then 2 squared. It's basically like this. 2 squared, keep the negative, right? So this one is a -4. This one is -2 squared, or -2 times -2, which is a +4. A lot of times you have this type of problem, and in a majority of them you really do, whether you're putting a number in for x squared, other situations. But you type in this problem on your calculator and get the wrong answer because you're in a hurry, you're using your calculator. If you think through these and don't use your calculator for the squares, then you'll probably get more of the answers correct. Okay, let's look at a couple tricky things too. What if I have something like 1/3 to the 3rd power? So if I have a fraction to a 3rd power, and I just did numbers on this one, but you will end up with letters in them as well in this section. But what we want to think of this as, I can break it up into 1 to the 3rd over 3 to the 3rd. So that exponent can move on to each numerator and denominator separately, and you could break it up. So 1 to the 3rd would just be 1, right? Because 1 times 1 times 1 is 1. And 3 to the 3rd is 3 times 3 times 3. So we can see 3 times 3 is 9. 9 times 3 would make 27. Okay, and you should have a key on your calculator to things to the 3rd, 4th power, and because we're in the exponent, I'll show that on this one. So most people have a TI, whether it's the big fancy one or the little one. The TI, this little caret, and also this is a shortcut on your keyboard. Above the 6, this means exponent. So I can do 2 and then to the 3rd, and that means 2 to the 3rd, and we should get 27. I mean, not 2 to the 3rd. What did I do? 3 to the 3rd. Sorry, I was like, that's not 27. 2 to the 3rd is 8. So 3 to the 3rd, and I should get the 27 I just got. So this key here is an exponent key, and that could help you. Okay, also note on this type of calculator, this is your minus sign and your negative sign, and that's different from your minus sign. You have to use this negative sign in front of a lot of different numbers, so be careful of that as well. Okay, let's start this was just some basic look at exponents. Let's look at multiplying with exponents. So multiplication with exponents. That's kind of what we're covering on this one. I might raise this up a little bit more. I love this new little tool I got this year. Let's see. Ooh, nope, wrong way. Okay, so multiplication with exponents. The rule is that you keep the base and add the exponents. Oops. Keep the base, add the exponents. That's kind of my rule for this one. Let's see what that looks like and what I'm talking about. Okay, so let's look at the first type of problem I have. What if I want to take x squared and I want to times it by x to the third? Okay, first of all, the base is the x and the exponents are the 2's and the 3's. So it says keep the base. So first of all, oh, and I should have probably included in I try to keep my definitions short, but you keep the base, but it has to also be the same base. You can't multiply or combine an x and a y, for say. So let's look at this. We'll keep the base and add the exponent, so it becomes x to the fifth. Why am I adding the exponents? We like this short because otherwise the shortcut idea is like thinking I have 2 of these times 3 of these. How many total do I have? So when the numbers get really big, we don't want to have to think about, okay, I had 2, I have 3, so totally, if I combine them all, I'm going to have 5. But that's the logic of it. So we are obviously going to step this way up, and we're going to add letters, numbers, and all sorts of things. So let's look at a little bit more basic one. Okay. So this is again a multiplication, and we could have used parentheses and put a parenthesis around each section, and that would have meant the same thing, right? Parentheses times by each other mean, or next to each other means times. So we start with the numbers, and then we can look at each combination of letters separately. So we start with the numbers, and we're timesing, so we times the numbers. -2 and 3 make -6. Okay, then x's. We have a fourth and we have a fifth. So total, we add those, we're going to have x to the ninth. So add those together. Now combine the y's. When I have y, it's like a 1, right? So we're going to have 1 and 4 make 5. So be careful of that. And what happens when this one doesn't have a z and this one has a z? Well, that means you just keep the z. Right? You just kind of combine it at the end. So I combine what I can together by using this rule of keeping the base and adding the exponents, and then keep anything else. So you could kind of simplify it that way. One other one that lots of people mess up. What if they're a base of a number? So what if I have 2 to the 10th and I want to combine it with 2 to the 2nd? First of all, these numbers are really big, so to take them out and multiply them is not something we want to do. We want to keep them as an exponent. So what we do is we keep the base of 2 and we add the exponents. 10 and 2 make 12. All right, I'm going to go ahead and pause real quick before I look at the next rule.